Hello students, this is Dr. Faizan Mirza. In this video, I'll be discussing a question regarding colorimeter. So this question came in October November 22, variant 52, and the question deals with the details of how a colorimeter can be used and how you should actually need to know and recall how to calibrate it and how a colored solution can be placed in it to find out its absorbance. So the detail provided to you in this question is that egg albumin, which is egg white, is good source of protein. Some eggs contain up to 10.0 weight by volume or 100 gram per dm cube of protein. So this volume, or sorry, this concentration is provided already to you. A biuret assay can be used to determine the concentration of protein in an egg albumin. Biuret reagent is a mixture of copper sulfate and sodium hydroxide. In biuret assay, biuret reagent is added to a solution. Proteins present copper to ions in the biuret reagent bind to the nitrogen atoms that form the peptide bonds. This binding causes the reagent to change the color, and pale blue or pale blue to a purple color is seen. Different concentration of protein result in different intensities of purple color. A colorimeter can be used to measure the differences in the intensity of the purple color in the samples tested. So it's very obvious. Stronger purple color would actually mean there is more protein present. Figure 1.1 shows a colorimeter that measures the absorbance of light when it passes through different colored solutions. So this is the colorimeter, and you can see that it is mentioned that here you are having 0.0, here you are having 0.04, 0.13, and 1.44. This is the absorbance given to you, and you can see that this is provided as A, B, S. This is absorbance. So what do we have? We have four different cuvettes, and cuvette is a special tube, glass tube, which is placed in the colorimeter with a solution, so you can test for the absorbance there. So this is the 3 cm cube volume inside the cuvette. Initially, you are placing a blank, which is the water only, then a cuvette with a solution which is colored, then a darkly colored solution, and a very dark colored solution. So you can see most absorbance by this and zero absorbance by this, which was initially the first blank. Outline how a colorimeter is used to set up to test cuvette can be placed in the slot to obtain a correct measurement of intensity of a colored solution. So how the colorimeter works? So what do? You first of all pick up a certain wavelength or a colored filter. You select it, and from the settings, and the cuvette is then filled with water. You will add 2 cm of water, and the light is passed in the colorimeter, and it is calibrated to 0. This shows maximum transmission of that wavelength of light through water, which is used as a standard for zero absorbance, because all the light will keep on crossing, so everything will cross and there will be nothing absorbed here. So you will calibrate this value as 0. A student carried out a biuret assay to determine the concentration of protein in egg albumin of eggs produced by a chicken that had been fed on a new type of chicken feed. The eggs produced by the chicken before eating the new feed contained 6.0 weight by volume percentage, weight by volume of protein in the egg of albumin in the egg albumin. Egg albumin is diluted to obtain concentration that is suitable for testing in the biuret assay. For example, egg albumin with 6.0 weight by volume protein is diluted by a factor of 10 to obtain 0.6% weight by volume solution for biuret assay. So 6.0 weight by volume is diluted by a factor of 10, so you get 0.6%. This is a hint provided to you how you are supposed to carry out the dilutions. To carry out the biuret assay on egg albumin of unknown protein concentration, a calibration curve needs to be produced. This involves using a standard solution of known concentrations of protein. The range of concentration of that can be measured using a colorimeter in the biuret assay 0.1 to 1.0 weight by volume. This is what you can measure. So what do you do here? What will you end up doing here? This is what we'll be discussing. A stock solution of 1.0 weight by volume of protein can be diluted using distilled water to prepare standard solution of protein. Describe how the student could prepare 0.1% solution of protein using a stock solution. Construct a table to show how the calibration curve of the biuret can be produced. What do? We have the volume of stock solution, protein 1.0 weight by volume, which is provided to us. This will be 10, 8, 6, 4, 2, 1, as I have described this previously in my other video as well. So what I'll do, I'll make a standard solution of, I'll make a range of solutions from it. If I add 10 of this and 10 parts of this with 0 parts of water, my percentage solution is 1.0%. If I add 8 parts to 2 parts of water, I get 0.8%. If I add 6 parts of this weight by volume and this 4 cm cube, I get 0.6. Again, 4 with 6, I get 0.4. 2 with 8, I get 0.2. And 1 with 9, I get 0.1. The table must have the units mentioned at the top and not in the body of the table. Percentage should be mentioned. Again, all the units must be placed appropriately at the top of the table. Now, not only they have given you the space for the table drawing, they have asked you to give a description as well. So what the description will be? 6 beakers are labeled for these percentages. Solutions. Using information in the table below, the stated volume of 2 cm cube of stock solution is transferred to each beaker using a syringe. Stated volume of water added to each using separate syringe. Each solution is then stirred using a separate glass rod. This is how standard solutions can be, a range of solutions can be prepared. Identify the dependent variable when you're prepared for the preparation of the calibration curve. Again, you will go for the simple cause and effect. So the independent variable is the protein concentration and the dependent variable here is the absorbance. Complete the figure 1.2 by labeling X's on the sketching of the graph for the calibration curve. Although we call it as a curve, but this is normally a straight line. Although you can draw a curve as well, but this is normally a straight line. So absorbance in arbitrary units will be on y-axis and protein concentration on the x-axis. So if you increase the protein concentration, the absorbance will increase linearly. So the graph should show a positive linear correlation, or you can say a positive linear rise along the axis. In the biuret assay, that the biuret assay assumes that if the same intensity of color that the biuret test is obtained with the test sample and the protein standard, then protein concentration is the same. Even though there are different proteins, there's the summarized proteins in standard solution, test sample, both are taken for the biuret test. Same intensity of purple color is obtained. Assumption, same concentration of protein in both solutions. Use information on the biuret test given on page 2 to explain why different proteins of the same concentration will result in the same intensity of purple color. So why same intensity of purple color is there? Because the copper 2 ions, we were told they bind to the nitrogen atom in the peptide bonds. There must be the same number of peptide bonds present in the protein standard solution and the test sample as well. So if they are both having the same number of peptide bonds, the same number of nitrogen atoms, so same number of copper 2 ions will attach to them and same purple color intensity will be observed. Describe how the student would use the standard protein concentration prepared in V1 to obtain the calibration curve. Determine the concentration of protein in the egg albumin of the eggs which is the chicken is fed on the new chicken feed. Do not repeat what is mentioned in A. Use how the colorimeter is used or how the standard protein solution would be prepared. So you don't need to add these details anymore. Although you already are provided with the space for that and you got marks there. Your method should be detailed enough in a logical way for the persons to use. So again, you will go for variable procedure, safety, and reliability. So all this must be included. So what I'll do, what basically are they asking? They are asking us to have a range of solutions that are prepared, that were prepared here. I'll be testing all these solutions in the biuret assay using them in this condition. So I'll place one of them one after the other in each of these you can say colorimeter, and I'll note down the absorbance. I'll select the filter and I'll make sure that I have given enough time for the purple color to form before I place it in this colorimeter. So when I have the conditions known, when I have the test run for the known sample, then I place my egg albumin sample, which is from the chicken feed. I'll dilute it and I'll place it for the biuret assay as well, and I'll note its absorbance, and then I'll compare it with my standards, or you can say the calibration curve. So how do we go about this? Known protein concentration solutions are placed in separate cuvettes in equal volumes. 1 cm cube of protein solution, 1.0% is added to 1 cm cube of biuret solution. Timer is started for 5 minutes. After 5 minutes, you will have purple color there. The cuvette is placed in the calibrated colorimeter. Absorbance is recorded. Record the absorbance for all the dilutions prepared in the same way: 1.0%, 0.8, 0.6, 0.4, 0.2, and 1.04%. All readings are taken by keeping 1 cm cube of the known protein concentration solution and the biuret in the same volume left for the same 5 minutes. All these, further you need to mention all these 6 range of solutions are replicated 3 times to find the mean absorbance for each concentration, so the anomalous values can be removed. Calibration curve is plotted 1 cm cube of aluminum. So this is how the calibration curve stuff is completed. Now you will move on to the detail for how the unknown protein sample can be tested for the biuret assay. So 1 cm cube of aluminum from eggs from the chicken feed on new feed is diluted by a factor of 10, because this was told to us previously in the question that you are diluting it by a factor of 10, and the absorbance is recorded after adding equal volume of biuret and allowing it for the 5 minutes. So again, we'll take the same volumes of 1 cm cube of these both, and place them for 5 minutes, and then place them in the place this cuvette in the colorimeter. Protein concentration is read off from the calibration curve, because it will already have my range of concentrations and the absorbance. I'll just locate the absorbance of this unknown sample, and I'll read off the concentration from there. The protein concentration is read off from the calibration curve and multiplied by the dilution factor, which was 10, to estimate the actual protein concentration. So this is all the procedure and the variables and reliability as well. But what about the safety? Safety again, you need to keep in mind, since copper sulfate is being used, it's toxic. Do not pour this down in the sink. Use gloves, because biuret reagent or even copper sulfate, they can be irritant for the skin. Again, this was for 6 marks, because although it had a lot of description, but they had given the description, or you can say they have just divided some description initially of how the colorimeter needs to be calibrated and how the range of solution needs to be prepared. So that's why the final designing question is not for 8 marks. I hope this video was helpful for you. What I want you to do is go and pick this question and start to try to attempt it by yourself, and opt for other variants of this paper as well, because they all came for dilutions, and you will find other colorimeter questions as well. So practice from those as well. I hope this video was helpful for you. Thank you so much.